So, picking up in 8.2 where we left off. I need to write on this, so I can down this thing and write on the screen. So right here is the XY axis, or the plus. The top one is y equals just 1 times x squared. And this one on the bottom is y equals negative x squared. That's where we left off last week. And we plotted our points, we put in some numbers, and this is what happened. When it was positive 1x squared, positive 1x squared, it opens up in the positive direction. But when you put a negative in front of the square, a negative is always going to lift your graph across the x-axis, no matter what. No matter what you're graphing, a negative in front of the function will always flip it across the x-axis. It's a vertical flip. And I'm not trying to scare you, but in trigonometry, we graph things like the sine curve. Y equals the sine of x. And the sine of x looks like this. It starts here at 0, 0, and it goes up. It comes back down, and it goes here. And it's a periodic function, which means it will complete that oscillation all the way to infinity. It'll keep doing this forever. And it goes this way to negative infinity. That's what it looks like. That's positive sine x. If I put a negative, y equals a negative in front of that sine x, then everything that was positive is now going to come out with a negative in front of it. And everything that was negative is going to come out, negative times negative is going to come out as a positive. It's going to flip it. A negative is going to flip it over the x-axis. So it would look like this. It would go down first, and it would repeat this. It's just flipped upside down. When you put a negative in front of any kind of function, it's always going to flip it. From what its parent function looks like, and the parent function y equals 1 times x squared, it's going to always open up. If you put a negative, they're going to be negative. It doesn't matter where the graph is, it's always just going to be upside down. That's why we start to build the equation of the general form, parabolic form of the equation, one piece at a time. And we start to analyze what's going on, one piece at a time. Okay? And then once we get to one piece at a time, we start to realize I don't need to plug in numbers anymore. I need to know what these pieces mean. And then I can plot one simple point. You plug in a couple of other points just to get the accuracy and the symmetry. So over here to the right, your left. This is what we got so far. Let's follow the calendar real quick. So today we want to hopefully get through 8.2 and start with some 8.3. I'm going to post 3 practice quizzes on Canvas tonight. 3 practice quizzes that are going to be just like the quiz on March 3rd, just like different problems. On Thursday, you basically want to finish up these 3. Then I'm going to post 1 more practice quiz. Again, just like the quiz you take on March 3rd. Because remember, the quiz you take on March 3rd, open, no, open whatever you want to have open. You can have posting quizzes out as your notes. Okay. Start with 9-1, we got the time. Then next Tuesday, 9-1, 9-2, 9-3, and then 9-3, 9-4, Thursday, take our quiz. I want to take the quiz here so I can give them back on the day of review, and then the test is on 10. So I'll change the due date on the homework. Okay. But when I say over here, I'm going to show you what that practice quiz looks like. So that's a line. We're going to learn about absolute value today. We know what squares do, parabolas. Then we'll learn about what plus 2 is doing. It's a positive 1x squared. 1 times x squared. Not. First thing you want to notice, it's a positive x squared. There's no negative in front of it. It's going to go up. Like I said, there's 5 questions. Square roots, and then that 5th one is a piecewise. That's an 8.3. What I'm going to post today is coming with the solutions. You're going to get the answers to the practice quiz. There's 6 pages. The answers. Now, whether you choose to actually do these, that's up to you. These reviews are always your choice. But there's 3 of them, and the reason why 6 pages is because each one has its answers right after this. A, B, C. B, B. Just so you see, this is the mock-up of the quiz, one that you'll take in class. We have 5 different problems. One of them will be a line, one will be a parabola, one will be an absolute value, one will be square root, and piecewise you can go back. 50 points for the 10 points. Just so you know, here's the chapter 8-9 review. Write the equation line parallel to this through the point. Equation line function notation through the points. Perpendicular to the x-axis through the point. Perpendicular to the line through the point. I already showed you, already played my hand, showed it last week. You're going to get parallel or perpendicular through the given point using function notation, and you're going to get one that goes through 2 order pairs. This won't be on there, the test point. Okay. And then on the review. Now there's lots of practice problems. Graph the following equations from basically what we've been doing. The first 4 of them are all linear. These are y equals -4, ax plus by equals c. That's a linear. That's a line. That's a line. They're all linear. So basically, it's chapter 3. Right here. Here we go. 8.3. Parabola, because it's a square. Square root, we're going to learn about. Absolute value. Square root again. And then another parabola. Practice. And as usual, they always come with the answer back. I'm only going to ask you, I'm going to ask you all of those. One of each. One of each. Just like the quiz. Right. You know what A does, you know what happens if it's not. So right here, right now, A is the coefficient that's in front of whatever's being squared. A is in front of whatever the square is. So right now, if A is greater than 0, greater than 0 is positive. If it's a positive number, 3x squared, 2x squared, 1 times x squared, 1/3 times x squared. It's a fraction. If it's positive, it's going to open up. If it's positive, it opens up. Just like the U in the word up. When you're positive, you're happy, like a smile. If A is less than 0, less than 0 are negative numbers. Anything less than 0 is a negative number. If A is less than 0, then it's going to open down. Like a frown. -1, -5, -1/3. Anything negative in front of the square is going to open down. So you know ahead of time, you're making a little list. I'm going to show you. You're making a little list. What's the A? What's the H? What's the A? Those are the things you need to know to make it happen. Now, what if it was 2 times x squared? So here's the deal. Real quick, I'm going to show you what 1x squared looks like. Just 1x squared. This is what we did the other day. So it's here 0, 0. When we plugged in 1, we got 1. When we plugged in -1, we got 1. So this was 1, 1. This was -1, 1. So this is just the last word. When we plugged in -2, we got 4. And when we plugged in +2, we got 4. Again, symmetry. To the left and the right side, they have the same one value. When we plug in -3, we got 9. When we plug in +3, we got 9. And so it opens up because it's 1 times x squared. And that's our basic parent curve. 1 times x squared. So I'm putting that back up there to see the comparison between the next two there. If I make it a 2 times x squared, and I'm not doing it right. Monica, if I don't move the camera, you gotta give me a shout out, okay?
Okay.
Sometimes I forget. So if we go with this y equals just a times x squared, and we're trying to play that little matchup game, and you have 2x squared, right now I would say a is a positive 2. And because it's positive, I know it's going to go up. That's the first thing I'm looking at. A is a positive 2. I know I'm going to make sure I draw this thing up. I've seen students write down positive 2 and still draw it upside down. And it just kind of boggles my brain a little bit, but it happens. So we don't need as many points. We already know. We already know what it's going to look like. So we don't need to plug in as many points as we have. So instead of all the way from -3 to +3, I'm just going to go from -2, -1, 0, 1, and 2. That's all I really need to do. Because I know it's going to have symmetry. I know what's going to happen later on. We're plugging it into 2 times x squared. So if I plug in -2, f of -2 is equal to this 2. And then when I plug in that -2, make sure you use parentheses, -2, and you're going to square it. So when you plug in -2, we get this 2. A -2 times a -2 is a +4. 2 times 4 gives me 8. So the ordered pair, we plug in x is -2, and the y is an 8. So when we plug in -2, the y is an 8 right here. And 1. So f of -1 is a 2 in front, and then -1 is going to square it. So f of -1 is +2. -1 times -1 is +1. 2 times 1, 2. So when x is -1, we get +2. So when x is -1, it's right here. That's +2. And then let's see what happens here. F of 0 is 2 times and 0 squared. So f of 0 is 2 times 0 squared is still 0. 2 times 0 is 0. So the point at 0, 0 hasn't changed. It was 0, 0 with our parent function, and it's still 0, 0 here. And that's f of 1, 2 times the square root of 1. And we get 2 times 1. And that's a 2. So we start to see how the symmetry plays out. When +1 goes in, it's now, instead of being smaller and smaller, it's going back up. We're at 1, 2. So right here, at 1, 2. At -1, at -1, we were at +2. And then to the other side of the y-axis, we're at 1 +2. That's the symmetry I'm talking about. The vertex is right here. The vertex is right here on the left side. You plug in -1, so 1 to the left, the y is 2. So 1 to the right, the y is 7. So we can make predictions. I don't need to plug in the 2 minutes. When I plug in 2 to the left side, 2 to the left of the vertex, 2 to the left, the y is 8. 2 to the right, the y should be 8. That would be right there, 2, 8. And so the graph is on the left. That actually supposed to look a lot better than that. All right, this should be different order. Move that inner cylinder. Not that crappy one, the rest of it. Right. Compare. What's the red one doing versus the black one? What's that compare? What give me a word? The red one is more wood. Smaller, that's close, simply because small, they're going to go up forever to infinity. So it would depend on how you measure small. Skinnier, well, that's not shady. But sharp is a good word. Sharp is a pretty good word. But I'm looking for, you know, you ever been down a residential street where it's not narrow? It's more narrow than the other. It's more narrow. Because the y values are happening twice as fast as 1x squared. Every y value is twice the height of the last original value that we plugged in. Instead of 1 giving us 1, it gives us 2. Instead of 2 giving us 4, 2 gives us 8. -3 goes in, we get 9. -3 squared is 9, but then you double it, it's going to be, I can't reach that high, 18. That's why I didn't plug in the -3. Every y value was happening quicker, faster. It's twice as, you might say, it's twice as fast as 1x squared. But it's narrower because it's happening quicker. It's more narrow. So that's another thing that A controls. A controls the width. So if we can make it narrow, we can make it wide. And the way you make it wider is this. Instead of a 2, let's make it a 1/2. So instead of a 2 right here, we're going to multiply everything by 1/2 instead. So 1/2 of 4. Half of 4 would give me a 2. When I plug in -2, I get 2 instead. When I plug in -2, I get, that's right, I get 2 instead. It used to be up here at 4, but now it's half the height. Half of 4 is now 2. When I plug in -1, Negative 1 squared is still 1. 1/2 of 1, half of 1 is a half. So when I plug in -1, out comes a half. So it's half a half from 0 to 1. Right here. -1 is going to give me a half. And half of 0 is still 0. This has not moved. That's the right there. And then look at the repeats. 1 squared is 1. Half of 1 goes back to a half. Now it's heading back up. Right here. 1 goes in, we get a half. Then 2 goes in. We're going to get half of 2 is 1/2 of 2 squared. That's 1/2 of 4. Half of 4 is a 2. Simple, right here. And that is more wide than the original 1 times x squared. So not only does A control ups and downs, A controls the width of the function. So over here to the big one. Now, on the review sheet, the big one, the one with 6, the 6 pages where you have the 3 practices and the 3 answer sheets, it's going to come with all sorts. You might change the A. I'm trying to keep your quiz and your test really simple. It is a 1 times x squared. It would be a -1, so might have been down, but I'm not going to change it to a 2 or a half or anything like that. Just going to leave it 1 or a negative. So you're going to move it up or down, but it's not going to change the width. But you need to know that A does. And here's how it works. If the absolute value of A, if the absolute value of A equals 1. Now, these are not good absolute values because it could be a negative x squared, it could be a positive x squared. Negative or positive. Okay. So it doesn't matter whether it's negative. If it's negative, it's just going to go here. If it's positive, it's going up. That's all we care. But if it's a 1, we call that normal width. Because if you're going to have something wide versus narrow, then you've got to have what are we wider than, what are we more narrow than? What's the actual, original? What's the OG width? 1 times x squared. Yeah. The absolute value of A is greater than a 1. I'm using the absolute value because maybe it's a positive 2. Absolute value of 2 is 2. Maybe it's a negative 2x squared. If you had y equals -2x squared, so A is a -2 right there. So you know it's going to go down. When you graph it, you better draw it down. The absolute value of -2 is +2. That's what I'm concerned about. If the absolute value of A is greater than a 1, it's going to be more narrow. Then 1 would be more narrow than what 1 would be. So anything bigger than a 1 or anything less than a negative. -3. Absolute value of -3 is +3. +3 is bigger than 1. It's going to be more narrow. Okay, equal to 1, greater than 1, there's only one thing left. What would it be? Less than 1. If the absolute value of A is less than 1. Now, the only thing that would fit would be fractions that are less than 1. Because the only thing that's going to make it wider is when you're not going up the stacks. Now, I say fractions less than 1, or all the way from -1 to 1. You can have fractions that are bigger than 1. 5/2 is a fraction, and that is equal to 2 1/2. So that's greater than 1. But it's a fraction. So don't think every fraction, just fractions that are smaller than 1. That means the numerator has to be smaller than the denominator. But less than 1, it's going to be more, it's going to be wider than the normal A equal. Piece by piece, we're making these pieces fit. So we're trying to build the general equation of gravity. And the general equation is basically called vertex. The vertex form for gravity. And that's basically y equals a times x minus parentheses x minus an 8 squared plus the k. Now we know what a is. Ups and downs, normal width, wide or narrow width. And now we just got to figure out what the h and k is. Now remember, it could be a y or it could be written as f of x. A minus 8 squared plus the k. So we have something to compare this. I'm going to put this right here as our y equals 1 times x squared. This is our parent graph. 0, 0. We have -1, +1. We got 1, 1. Okay. Now I want to make sure we're clear about it. graph and label the following equations or functions. Only 2 points are necessary to graph a linear equation or function. So if it's a line, all other functions will require 3 or more for accuracy and symmetry. Now, I'm going to amend that. I'm going to say that parabola means 5 because I want you to be accurate. Now, that does not mean you got to plug in 5 numbers. That means you got to find the vertex. And what you should do is plug in 2 more numbers and use symmetry. Symmetry. Explain. So, this is what I'm talking about. Right now, in this equation, if I try to match things up with y equals a parentheses x minus h squared plus k, and all you're looking at is y equals x squared. You should do, first thing you should do, identify what does the a equal, what does the h equal, what does the k equal. Those are the 3 things you need. So y equals x squared. So a in front of this x squared would be positive 1. X minus h squared. Do you see a parenthesis here? Yes or no? No. Since you don't have a parenthesis, that means inside that parenthesis, the only thing that will be just x squared would have to be x minus h has to be a 0. That's the only way to just get x squared all by itself. The only way to end up with just x squared is to put h is 0. X minus 0 is just x squared. H is a 0. Do you see anything added after the square? Is there anything here plus or minus something? No, there's nothing here. It's just 1x squared. So that means the only way that you have nothing here is because the k was a 0. A is a 1, everything else is 0. That's all we start with. That's a current function. H and the k. Alphabetical. H is first, K is second. The H and the K, if you remember that 0, 0, H is 0, K is 0, is exactly where the vertex was. You don't have to label the origin, just plot it and call it good. Now, if I want to graph this thing correctly, I need at least for a pen or for any for parabola 5 points. All you need to do is plug one number to the right of the vertex. So the first number to the right is 1. What's 1 squared? 1. So when I plug in 1, make sure you label it, I get 1. Symmetry. If 1 to the right of the vertex is a y that's 1, then 1 to the left of the vertex, 1 on the left, -1, is also going to be a y that's equal to 1. I don't need to plug in -1 anymore. I could just do symmetry. And if you notice, I told you to go which way? Go to the right. Go, anybody see poltergeist? Carol Ann, go into the light. You want to go to the right. Okay. You want to go to the right. if you stay to the right, then what you have inside, whether it's something like this, you have a minus something, it will be a positive u squared, and you won't have to worry about having a negative. You want to avoid negatives in parentheses if you can. So if you stay to the right of the vertex, you'll end up with positive on the inside. Go once, and right now I have 3. And here's why I want 5. I used to just want 3 because I'm tired of this. You overgraph this, and it would be a parabola, so they get this right. And make that curve, and then you do this. It's not this. Okay? Parabolas go out forever. You're going to get all the x's to negative infinity and positive infinity, and the y's are going to go out forever. Okay? So when you go straight up, that means all of these x's are 1. That's a 1, 3. This is a 1, 5. And if you have all of them as 1, you don't have a function anymore because x can be. So don't draw it straight up. So now, if you do 5 points, I said a summer in 5 points. I don't know what 5 points is. Go out past Riverdale. There's an intersection where 5 roads intersect at once. That's where I worked 10 p.m. to 6 a.m. No, it was Campbell's tomato soup place. I was testing tomatoes for the city. I think it was $15 an hour, 7 days a week, because I was working graveyard shift. On the 6th day, I got time and a half, and on some days I got double. Plus they paid mileage. And so it was only during that's like a 5-week period. But it was my last real job before I was a young 23 or 24. Even though I'm still awake all night long, I didn't. All right, so go 1 more to the right. You already went 1 bit, go 1 more to the right. So we're at 2. 2 squared is 4. 2 goes in, we get 4. So if we go 2 to the left, negative 2, we're going to get the same y value as the 7. Negative 2 is going to give us positive 4. So now you have an actual point to aim for. And that will establish a better parabola. I only plug in 2 numbers, 1 to the right, 1 more to the right, and use symmetry on the other side. That's our parent. So now let's do 1 times x squared plus 2 plus 2. So first pop quiz. Is that the H or the K? H with, you think about alphabet H, alphabet K second. H messes with your X's. H has to be, if there is an H, it has to be in parentheses with your X. Has to be inside with your X. H is a H for horrible. H is a horrible person who's messing around with your X. Okay. K is after the square is happening. K comes after the square itself. It's either added or subtracted after the square. So Is there a parenthesis? No. So that must be the K. So, and that's why when you do these, I always write up above it, f of x equals a parentheses x minus h squared and then plus k. So we can get a little readout on a is right here, 1. And because it's a 1, it's going to go up. There's no parentheses, so right in here, h would have to have been 0. K comes after the square, so after the square, I see plus 2, so k must equal to 2. I'm going to plug in -2, -1, 0, 1, 2. Because we just want to get an idea of what this is going to look like. So f of -2 is parentheses -2. You're going to square it, and then we add 2 to it. So when we plug in -2, we get +4, and then plus 2. That means we get 6. So when -2 went in, the y value is a 6. So that puts it here at -2 +6. -1 goes in. -1, we're going to square it, and then we add 2. The f of -1 is +1 plus 2. 1 plus 2 gives me 3. So when x is -1, we get a 3. X is -1, it's square root of 3. -1 went in, we got a 3 out. And then every time we plug in 0, we can get 0. Let's see. After 0. So 0 squared, but then we add 2. So we plug in 0, 0 plus 2 equals 2. So when 0 goes in, we now get a 2. That's right here. Remember, if it's on the axis, whether it's y-axis or the x-axis, we use one number. Remember, if you're using one number, don't put parentheses around a single number. And then we plug in +1 to see if it has the 7. +1 goes in. +1 squared, and then you have to 1 plus 2, and that -1 gave us 3. +1 gives us the same like that. So yes, I think it's a 7. 1 gives us 3. Check. +2 times 2. 2 squared, and then plus 2. The last time we plugged in that, that's it. So f of 2 is 4 plus 2, and we get 6 again. So symmetry still holds. To the left, 2 away from the left is 6, 2 to the right is also 6. This parabola looks like this. And what's the difference between the first one and the second? Our parent graph and what's it equal? What's that? It's not on the vertex anymore. What has happened? It's been what has happened to the vertex has been. Is it narrower? When you went one to the right on the original, one to the right, we got one. So this was 0, 0, and it went one to the right, one up. When we up the vertex here, that next point is one to the right, one up. It's the same. This is one up, one over, one up, one over. Is it the same width? Yeah, it's exactly the same width. It has to change the width because the only thing that can change the width is A. A is one still. A is still one. The width is normal width. What has happened to all the y values? The old y values, 4, 1, 0, 1, and 4. What happened to those y values after you did the square? You did what? We added 2. So that means we took all these old graphs and they all got pushed up 2 units. Every single ordered pair is now basically shifted. It's been shifted up 2 units. It's kind of like you took that parabola. They took that parabola and you shifted it up 2 units. It remains the same parabola, it's just moved to a different spot. That's what K does. K is the vertical shift. K is the vertical shift of the parabola. So since K is a 2, everything gets pushed up 2. And since we already established that H was 0, K was 2, the ordered pair HK 0, 2 is exactly where the vertex is. That vertex right there, it used to be at 0, 0, now it's at 0, 2. If I add 3, everything gets shoved up 3 units. If I add 5, everything's going to move up 5 units. What would happen if I went minus 4? Okay? That would be, or it would, all your old y values, all the old y squares, you now subtract 4. So minus 4, so 4 minus 4 is now 0. So the negative 2 goes in, you get 0. So negative 2 goes in, the y value is 0. When you plug in negative 1, so that's negative 1 squared minus 4. That gives me positive 1 minus 4. 1 minus 4, negative 3. So when negative 1 goes in, we get negative 3. Negative 1 goes in, we're down here at negative 3. Zero goes in. 0 squared minus 4 is 0 minus 4, which is negative 4. Let's see if it starts heading up. 1 squared minus 4 is 1 minus 4. And that is the same answer on the other side of 0, negative 3. Same as we got on the other side. So you can see that it's starting to head. Well, but in 1, it's symmetry, left side, right side. 1, negative 3 to start to get that up. So that means if I go 2 to the left, the y is 0. So if I go 2 to the right, the y is going to be 0. Symmetry. And then that's 5 ordered pairs, it's 5 points. old y values on the red one, you now take 4 away. So it used to be at negative, it used to be 4. It was moved down -1, it's now 0. The old y value on the original is at what? 1 minus 4, that got moved down to -3. This old y value was 0, it got moved down to -4. It got shoved down, it's a vertical shift of 4 units down from the original. K controls the vertical shift. If it's positive, you have a plus something, it's moving it up. If it's minus something, it's moving it down. The sign matters. -2 is moving down 2. +3 is moving it up 3. Remember, K is after the square. After the square. So we're going to take our rate, come on back at 46. 46. If you didn't get your rate back, come on to 2. Right. Okay. I have blank. Yeah, so I can cover things up. Oh. So K vertical shift. K goes up and down, and now Y narrows. K is the vertical shift. Now make sure you don't forget to put the F in the shift. F of X equals, this right here is just Y equals our character, Y equals X squared. We got the origin at 0, 0. This right here is 1 over 1 up. So that right there is at 1, 1, not the scale. 2 goes in. This is 2, 4. 3 goes in. 4, 5, 6, 7, 8, 9. 3 goes in, we get 9. Four goes in, it goes all the way to 16, 10, 11, 12 is what? So symmetry, 1 to the left, and -1 goes in, we'll get +1. -2 goes in, we're going to get +4. -3 goes in, we're going to get +9. What you see on the right is going to be over here on the left. So, that one put in. Now we're going to put in parentheses X -2 squared. X -2 squared. So A, H, K. In front of the parentheses, this is where A lives. So we made place to match this up. F of x equals a parentheses x minus h plus the k. In front of the parentheses, what do you see? So what's that? If it was zero times that, you have nothing there at all on the right side. It has to be a what? A 1. It's a positive 1, so it's normal width, and it's going to open up. You have parentheses then. You have parentheses, and the horrible h is messing with your x. In the parentheses, no matter what we're ever going to graph in your entire lifetime, inside, when you mess with x, it will always have to be a parenthesis. It's be a built-in minus x minus that, always a minus. That means the h that's in there is the opposite sign of what you see. In other words, h is a positive 2. Because what would h have to be equal to with x minus a 2? It would have to be x minus a positive 2. That's how you get x minus 2. Because the negative was already there. It was already a built-in negative. Okay? Already there. So here's another hopeful way to remember. I'm going to build on this every single time you do this. You need to say it to yourself as you do it. When you're finding the h, you take out the opposite sign. Opposite for h. Opposite of what you see. You see a minus, h is positive. When you see a plus, h is negative. I'll do the next example. Any graph you make, whenever there's something messing with the x, there will be parentheses, there will be x minus already there. H would have to be the opposite sign of what you see. So H is a positive 2. What's the K coming after this parenthesis? What's right there? You see it? Well, it has to be a 0. So let's just try some numbers. Let's try our usual number. Negative 2. Negative 1, 0, 1, 2. Parentheses, x minus 2 squared. The reason why I'm taking piece by piece of the parameters, because everything I'm showing you on the parameters is going to handle everything. When I plug in the negative 2, f of the negative 2, it's going to go into the parentheses, that x is now a negative 2, and then you subtract 2, and we square it. So that means f of negative 2 is equal to negative 2 minus 2 is negative 4 squared, and negative 4 squared, positive 16. So when we plug in negative 2, we get positive 16, which I can't reach because it's not even going to go up to. This is 9, 10, 11, that's 12. It doesn't work. So something's definitely happening. Negative 1. So in the parentheses, x minus 2. So negative 1 minus the 2 squared. So f of negative 1 is negative 3, and then you go square. And negative 3 squared, that's a positive 9. So when you plug in negative 1 for your x, we now get positive 9. Negative 1 goes in, we now get positive 9 over here. It used to happen at negative 3. It's now happening over here at negative 1. Think about it. We're messing with the x's. That means the x values are changing. Used to put 0, 0. Let's see. That's a 0. Now you're going to go into the parentheses. 0 minus the 2. And then you square. So when you plug in the 0, you get a negative 2, and then you square it, and gives you a positive 4. When 0 goes in, we get a 4. So when 0 goes in, the y value is a 4. It used to happen in -2, now it's happening over here at 0. Maybe that's my vertex. It comes down and goes back up. Well, the only way to find out is to go 1 to the right. Now, for 1, if that's the vertex, it should go back up. You should get something bigger than 4. If we have symmetry, it should go back up to 9. So that's 1 minus 2, and then you square it. So f of 1 is 1 minus 2 is -1 squared, and that's positive. It's not going back up. When you plug in 1, it's still going down. It's still going small. 1 goes in, and it's right here at 1, 1. So here's these points. -1, 9, 0, 4, 1, 1. So we plug in 2. F of 2, 2 minus 2 squared. So f of 2 is 0 squared. 0 squared is 0. Now we get our 0. When 2 goes in, we get 0. So now it's hitting here. That's 2. And again, because it's on the x-axis and it's able to put a single number, that's the number one. Remember, never put parentheses in that single number. Just label them as a big. So it hasn't gone back up yet. Parabola is supposed to come down and go back up. So we got to keep going. We got to go to 3 and see what happens. Maybe 4. And let's see what happens at 3. F of 3 is now 3 minus 2 squared. So F of 3 is equal to 3 minus 2 is 1. Squared. 1 squared, 1. When 3 goes in, 1 comes out, and that's bigger than the last one. So now it's going to up. When 3 goes in, we're now here. And so it's come down, and now it's starting to go back up. So now we know that it's a parabola. Yes. We know it's headed back up. I can start using symmetry. I don't need to plug it in. Why? If it's going down and starts to go back up, this must be the vertex. So if this is the vertex, symmetry happens to the left and the right of the vertex. So 1 to the left, we get 1, then 1 and 1. 1 to the right, so 1 to the right and 2 is a 3. The y value is a 1. We go 2 to the left. The y value is a 4. When I go 2 to the right, if this is 2, 2 to the right will be 4. And the y value should be 4. It should be 1. And if we're going to do one more because of the symmetry, this right here, -1 is 1, 2, 3 to the left. When you go 3 to the left, you get 9. So when you go 1, 2, 3 to the left, this y value would also be 9. And if this is 2, 3, 4, that's 5. That's 5, 9. Now, is going to go up to here. Now, A was a 1, so it's the one up and it's the same normal width as the regular parent. Same width, same normal, okay? And that doesn't change with our parent. K was a 0. H was a positive 2. Look where the vertex is. The vertex is right there at X is 2 and Y is 0. H was 2. K was 0. HK is exactly where you're going to find vertex. The ordered pair HK. Alphabetically, H before K. Alphabetically, X before Y. Alphabetically, H messes with your X. Well, you're not going to make the dot. Don't worry about that. I'm just dotting it so you can see. Shoulder messed up. Here comes the character. Here comes the new. There we go. Not too bad. Mine is at 11 points. It's really easy to make sure my graph ends up where their graph is because I wanted points. And I know what shape it is. All I have to do is draw that graph right through those points. Remember when the K shifted everything up? Well, look what the H did. It moved it 2 to the right. -2 is now where 0 is. -3 is now where -1 is. -1 is now a positive number. 0 is now over here at X equals 2. This used to happen at 1, 1. It's now 3, 1. That's been moved over to from 1 to 3. That used to be at 2, 4. Now it's moved over to 4. This used to happen at 3, 9. Now it's happening 2 to the right at 5, 9. Everything got moved to the right 2 because of the X minus 2. You see right and to the right. Positive. Now let's make this one last little twist. We're going to make that plus 3. Plus 3. Just graphing it on a calculator, copying it in, does not give you the credit. You gotta show me how you're getting some of these ordered pairs. You definitely have to show me how you got A each day on each. I don't want to take graphing calculators away from you. I want you to learn how to use technology, but I don't want you to just plug it into the graphing calculator and let it go work and you just copy it and go. Now we're going to use what we're supposed to know. See how well we do. I'll show you exactly what I expect. We're going to do x plus 3. So remember, inside there is y equals a times x minus h, your square, and then a plus k. In front of the square, a is a 1, as usual. Now, this is what students struggle with, figuring out what h is, and then mixing it up with h to know what's the a, what's the k, and seeing the things that aren't there. If you have a parentheses before the square, if there's something inside there, that's your h. If it's just x squared, no parentheses, you don't have it, h is 0. This is h. Now, the only way to get x plus 3, because it's a filled-in negative, inside that parentheses, it would have to be x minus, because it's a filled-in negative, and then the h itself is a negative 3. The h itself is a negative 3. A is a positive 1. And the h that's inside here, x minus h, x minus, what are we subtracting? We're subtracting a negative 3. And that's how we get x plus 3 in the division. H is a negative 3. But here's the thing, so you don't have to cancel it. When you take out the h, negative 3, take out the h, take out the opposite sign. Remember, that h is messing with your x. It's a negative person, a bad person. Negative thing, and there's take out the opposite sign. H for opposite. You'll start saying that in your brain so you can take out the opposite side. And then afterwards is the k, and afterwards we don't have a number, so when we don't have a number, k is 0. Now, according to what I'm telling you, the vertex is the ordered pair hk. So my vertex should be at negative 3, 0. If it's a negative 3, yes, because it would be a positive equation. On the first one we did, it was x minus 3. So h was a positive. All for h, you took out the opposite, you see my h positive. You see plus 3, h is negative. Opposite sign. Okay? All for h. You see how k has a plus in front of it? You keep the sign. Plus, you keep the sign. K for keep. H for opposite. How will you make sure you got it? You got it back. I'm giving you so many practice problems that are just like this test. You choose not to do the test. So here's what I know. First thing I'm going to do is I'm going to come over here, and I know my vertex is right here. 1, 2, and negative 3. That's my vertex. What else do I know? I know it is a 1, it's going to open up. So very likely, that makes sure this thing goes up. Just want to make sure it goes up. Because again, like I told you, I've seen students, they write down a is positive 2 and they draw it upside down. They go like this. A is positive 1, so it opens up. A is positive 1, so it opens up. And you draw this, and then over here, you draw it upside down. The reason why I do that as soon as I put the vertex is because when I plug, you got out, I want 5 full points. You got to plug in some numbers. If I get something below that, there's something wrong. There's something wrong. Anybody want to come up and ask? once you establish the vertex, what we should do next? If I want 5 points, you only need to plug in 2 more numbers and then you 7 it. So you plug in 2 more numbers, I told you to do what next? Going to go, the next number should only be 1 to the right. 1 to the right. Stay, don't go left. If I go left, -4. Inside, -4 plus 3 is -1. You end up having to take care of it. If you go left, you end up with negative. If I go to the right, I'm going to plug in -2. So I have x plus 3 squared. I'm just going to go 1 to the right, -2. Now put -2 inside the parentheses, -2 plus 3, and then we square it. So -2 gives me +1 squared, and that's a 1. So -2 at the times 1. So 1 to the right gives me +1, so that means 1 to the left is also going to give me +1. 1 to the left, this is -3, this would be -4, +1. Symmetry, because you know what the vertex is. 1 to the right of the vertex, 1 to the left of the vertex. You need 5, I got 3. I need to plug in 1 more number. Right, so I plug in -2, so now I'm going to plug in -1. -1. Now plus -1 is parentheses -1 plus 3 squared. So f of -1 is equal to +2 squared, and that's a 4. When -1 goes in, it's 4. Plug in -1. So if I go 2 to the right, I get a y value that's a 4. So when I go 1, 2 to the left, I'm going to get a y value that's also 4. So 2 to the left, -3, -4, this is -5. That's 1, 2, 3, 4, 5 points in travel. Sorry, this should be taken over. Go. Keep up the way the ones I drew. Go. So we established that A controls up and down. H is the horizontal shift. Only on the. So one last practice one, which would basically be just like an actual quiz book. That's one. Y equals negative x plus 2 squared plus 4. Negative x plus 2 squared. Negative parentheses x plus 2 squared and then plus. Here's how you take it apart these factors. We are basically want to play the lineup game. F of x is a parentheses x minus h squared and then a plus k. First thing, make a little list of who everybody is, what's the A, what's an H, and what's the K, and what's the vertex. I have to see what the vertex is, what's the HK. So what's the A in front of our square? -1. So A is a -1. So as soon as I see it's -1, it's going to go down. I want to make sure I get my brain right. It's going to go down like that. Then 8. Inside the parentheses, we have a parentheses, and there's something in there with X. So we do have an H. Pick up the opposite sign with H equals -2. And then plus K. Now we do have plus something after the square. So what do we add? A +4. So we have an H and a K. So the vertex of this is at -2, +4. So the first thing I'm going to do is I'm going to go label, not label the vertex. -2, +4. Left and then up 1, 2, 4. Label it. Now look where I'm labeling it. I'm labeling it above the point because I know it's going to open down. And I'm dropping it very lightly with the pencil. Very lightly with a pencil. Just going to open down. And I need 5 points, which means I'm going to plug in two numbers to the right, symmetry about the vertex here at -2. So what's the first one? This is -2. That's the first one that's in the right. -1. So I'm going to plug in negative parentheses x plus 2, and then you square it, and then you got 4. I'm going to plug in -1. F of -1 is negative parentheses -1 plus 2. We're going to square that, and then we have 4. parentheses first. Bring down the negative. -1 plus 2 is +1 squared, and then +4. F of -1. And then here you got to be really careful. Some of you know, it's like, even though I tell you to use parentheses, you refuse. If you refuse to use the parentheses, you see this, and you see -1 squared, so you put +1 plus 4. And you get 5. So when -1 was in, I just did this wrong. When -1 was in, you get 5, and so it's up here. Well, what if you just kind of get a little like here? It's supposed to go down. You plug in -1, and now it's going up. Something's wrong with what you did. You know it's supposed to go down from that. So, parentheses, the negative is not being squared. So that means -1 squared is still negative in front of that 1. -1 plus 4, +3. So -1 goes in, we get +3. -1, +3 is below that last one. Symmetry. You went 1 to the right, and we got a y value of 3. So 1 to the left. 1 to the left is -3. We should get a y value of 3. Label. Not label. So now we just need one more point to plug in and then send. So we've done 1 to the right, let's go 1 more to the right. For the main one, we can plug in 0. That's 0 is 0 plus 2, -0 plus 2 squared, and then plus 4. So F of 0 is bring down to negative. 0 plus 2 is 2 squared plus 4. So F of 0 at a negative front, 2 squared is 4 plus 4. -4 plus 4 is 0. So when 0 goes in, we get 0. So it's now going to hit through the origin, 0, 0. So it down like this. Which means 2 to the right, you get a y value of 0. So 2 to the left, over here at the you're also going to get a y value of 0. And now it's going to open down. Open down like this. If you notice, I don't try to draw the whole parabola in one swoop. I draw the left side and the right side. Over each arrows, this side. Smooth it. Now, terms of your homework, take a look at page 2. Not that you'll do everything yet, but you can do the ones that have the squares. You have some value in set just to get an idea of the basic curves. First of all, parabolas, x squareds are curves. Unfortunately, again, on homework, multiple choice. You're not grabbing by hand on your test equation. So this is x squared plus 5. So you know it's a parabola. A in front of x squared, that's a positive 1, so you know it's going to go up. There's no parentheses. So inside the parentheses, h would be a 0. After the square, you have a plus 5. So k is equal to a 5. So the vertex should be at 0, 5. Now, process of elimination. This one A and this one B are straight lines. They're not curves. So it cannot be A. It cannot be B. Because those are made out of straight lines, not curves. They're not parabolas. So now you have a choice left between B and C. So this is why the homework is a little less challenging than I'm doing. A is a 1 supposed to open up out of B and C. The only one that opens up is C. So there's only one choice. And if you notice, this vertex right here is right there. 1, 2, 3, 4, 5. That's the value. This one, g of x is 2x squared. G of x equals 2 times x squared. So if we make our little matchup, g of x is a parentheses x minus h squared plus k. H k. What's the a? Positive 2. And if it's positive 2, it's going to go up. Is there a parenthesis? What would h have? 0. Is there something added or subtracted out of the square? Okay, is it? So the vertex is going to be at 0, 0. Again, process of elimination. C and D are out because they're not grabbing, they're not smooth curves. So we either have a parabola that goes down or one that goes up. A is positive 2. There's only one answer. It's the one that opens up. This is why you need to do practice by hand. F of x is 3x minus 2. Is that a parabola? How come it's not a parabola? It's not a square. You don't have the power to. You recognize what this is? What? 1 times x, x in the first. This is just f of x equals mx plus b. So that's not a linear equation. That's not a linear equation. So it's either this one or this one. Which one? A or C? C, how come? Slope is a positive 3. Slope is a positive 3. When it falls, that's a negative slope. When it rises, that's a positive. graph. And 8.3 I want to show you how you comparison of this. Here you're actually graphing it. They want, so it's not multiple choice, but again, you're not graphing the same. We're graphing g of x in parentheses x minus 2 squared. Now, I don't like how they do this on this chapter. It's a little bit better in chapter 11. We're making our little setup. G of x is a parentheses x minus 8 squared plus k. What's the a in front of the square? Lots of to go up. Inside we have a parenthesis. So what would the h have to be? Positive 2. You know, the opposite sign. The opposite sign. H is positive 2. There's 0 plus k. There's a what? 0. So our vertex, hk, is at 2, 0. So you got to open this up at your capital line. You're going to click on the parabola curve. You're going to click on this, and you're going to basically follow the directions that it tells you. Click on the parabola curve. Now we'll drag it. Click the graph to plot the curve. So just click the graph. And it automatically puts a parabola at 0, 0. So that's where it puts the vertex at 0, 0. Then you have to do this. In chapter 11, it's a little nicer. So we're supposed to move the graph to 2, 0. Our graph should have a vertex at positive 2, 0. So we need to do basically horizontal shift. We want to go to the right. So we're going to move this to the right. And that's it. Hit save. Check the answer. Well done. Let's see if I have one of these here. There we go. So we have g of x in parentheses x minus 1 squared and then minus 6. Matching up with g of x, a times x minus h squared plus k. In front, a is a positive 1, so it's going to go up. Inside, what's our h and what's our k? Inside, what's that? Positive 1, because we see a minus, we have opposite side. K, we keep the sign. Because we see negative 6, k is 6. And our vertex, we'll compare k. 1, negative 6. So it's got it here. 1 to the right, and then down 6. Vertex is got to go right there. Click on that gravel curve again. Click on the graph, because it's going to put it at 0, 0. The horizontal shift is 1 to the right. Now, I think we use the arrow. 1 to the right. And then we want to go down 6. So, up. -6. Okay. Right. I'm just going to pretend that there's a negative in front of it so you can see what happens if you need to do an actual negative. So A is a -1, so it's going to go down. You've got inside H is +4, K is a -5, vertex is at 4, -5. So +4, down 5, and then I'm going to put my parabola down instead. On the parabola, right over here. I'm going to go 4 to the right. Down 5. And then right here, reflect about the x-axis, so that's this way. About the y would be left and right. So I want to reflect it about the x-axis box. And now should have reflected it. If you had, don't be wrong. That's okay. Should have reflected. That's the problem. But if you had to reflect it, that's how you turn it upside down. Everything I just did, even though I took all plastic, is now going to make the value. Hey, let me take roll. Tyler, Alan, Kyle, Marissa, Hannah, Diego, Don, Brianna, Derek, Julia, Oscar, Delia, Liliana Martinez, Tyler, Lynn, Ty, Helen, and Tika. All right, see you Thursday. All right, Monica, hopefully you're ready to go on Thursday.
Okay.
Okay.
Thank
You're welcome.